My name is Jeff Davids, and I'm the lead developer for the RemoteTracker project. The whole concept of the RemoteTracker is to make a device that makes measuring flow really easy. So agricultural water providers have a ton of pressure these days to increase their efficiency, be more transparent with the amount of water they're delivering to their customers. One of the pieces of all that pressure is being able to accurately measure the amount of water they're delivering to people. And the goal of the RemoteTracker is to provide a platform to do that, to do it easily, to do it accurately, to do it cost effectively. All those things are really the goals of the RemoteTracker product. The RemoteTracker system is comprised of three main pieces. First, there's the water velocity sensor that we deploy in the outfall of the pipe. Second, there is a computer system in the operator's vehicle that wirelessly controls the water velocity sensor. Lastly, any RemoteTracker data that's been collected onto the computer in the operator's vehicle can be wirelessly transmitted back to a server in the district office. Most districts have multiple operators in the field collecting data. So one of the benefits of having a centralized data server is that data from each of the operators that can then be aggregated to form a district-wide summary and then pushed back for viewing on the operator level. So essentially, if an operator makes a change using this cloud-based system, that change will propagate out to every other operator, and so it'll be visible within a matter of minutes. Most measurement methods, you have to change a gate setting and then go take a measurement, and then you're like, oh, it's too much, so I go back to the gate and change it. Oh, it's not enough. So it's this iterative process where you're going back and forth, But with the RemoteTracker, you can actually see the flow rate change as you adjust the gate. And so if if a grower calls and says, hey, I want 10 CFS, instead of having to guess what 10 is and then go measure it, and if you're high, shut the gate more, if you're low, open it up more, you can actually stand at the gate and watch that flow rate change and actually set it to 10. The idea of the RemoteTracker came from a series of studies in the Sacramento Valley where we were looking at alternative methods for measuring flows for these agricultural water providers. And we were really looking at using a gate for measurement and using a weir for measurement. And what came out of that study is that gates really have a lot of variability in their ability to measure flow. Sometimes they're low, sometimes they're high. Weirs measure pretty well, but they only work when you have a lot of energy or head pressure at that gate. And it just turns out that 75% of the gates that we've looked at don't have enough energy to measure with weirs. So really we started looking at, what are methods that we can measure flow with that don't require a lot of energy, that are easy, and that are accurate and reproducible. So during these investigations where we were looking at the gates and the weirs as potential measurement possibilities, we had to have a verification, flow rate. What are we going to compare the gates and the weirs to? So what we ended up doing was using an acoustic Doppler sensor that measured water velocity as kind of our standard or our absolute. And it turned out that during the course of performing those measurements, we realized that there was a really nice correlation between the center measurement of velocity and the average of the whole pipe. And utilizing this correlation, what it meant was all we had to do was go out and measure that center one time, and that gave us a good average if we could use this correlation.
Definitely the two goals we had for the RemoteTracker were ease of use and simplicity, so that when the user interacts with RemoteTracker, they have everything they need at their fingertips without a lot of options that they're not going to use. So our goal with RemoteTracker was just to make it as easy to use as possible. A minimum number of button clicks or interactions with the software to do your job. If you want to take a measurement, you hit a button and you take a measurement. And we spent a lot of time refining the features.
The focus on simplicity led us towards implementing a series of auto features. One of the auto features that we implemented was an auto locate feature, where when you pull up to a site, instead of having to select your site from a pull down list that has every single site in the district, we actually narrow that down to a certain radius and only give you the option of selecting sites that you're within a certain radius of. Auto start automatically starts the sensor when you pull up to a site. One of the parameters that we get from the sensor is whether it's in the water or not. And so as soon as we see that it's in the water, we have a delay period and then take a sample if auto sample is enabled. And one of the great things about that is that really you can take a measurement at a site without even pressing a button. So using the auto start and the auto sample feature, when you pull up to a site, it's going to start the sensor for you. When you put it into the water, it's going to take a sample. So essentially you've taken a sample at that site without even having to press a button.
And while RemoteTracker is still easy to use, it's still a full-featured device. We have a sensor tab. You can see all the sensor data and set different thresholds. There's GPS thresholds in there. You can see all the GPS data. So while it's easy to use, the data is still there and easy to get at.
So another feature that sets the RemoteTracker apart is that the velocity sensor is actually controlled wirelessly over a Bluetooth radio connection. It's class 1, so you actually get a 100-meter range out of it. A Bluetooth connection to the velocity sensor allows the operator to adjust the gate and the flow rate and see in real time the flow change without having to walk over to the sensor.
So yeah, early on in the design process, we were debating between whether or not this was going to be like a traditional desktop application or maybe more of a smartphone or a tablet-based application. And when we saw the application run on like a smartphone, we really realized the potential of RemoteTracker, and all of the design decisions from then on really fell out of having a touchscreen type interface on a smaller screen. So that's why we have large letters, large buttons. It's just big and supposed to be easy to use even on a small screen.
The first thing you want to do when you implement the RemoteTracker system is just go through your district and define all the locations where you deliver water. So with other flow measurement devices, you have to enter in the name of the site, all the parameters that are used to calculate the area, and then you actually go and measure the velocity. Once those things are defined in the RemoteTracker database, whenever you return to that site, those are automatically loaded into the program. So now all you have to do is go and measure water velocity, and everything else is done internally with the click of a button. How do we know that it works? How do we know that there's accurate flow data coming off the device? It's really important that we're getting accurate flow data, so we wanted to test that in a couple different ways. The first way we tested it was at the ATRC, it's the Ag Training and Research Center at Chico State. So we set up a turnout with a 20-foot length of pipe and deployed the RemoteTracker sensor at the outfall, and then compared the flow rates that were measured to flow rates with a magnetic meter, which is really a kind of an industry standard. On average, the RemoteTracker was within 3% of the magnetic meter. We also wanted to test the RemoteTracker out in the field. So we selected 2 deliveries in 2 different districts up in Northern California, and then compared RemoteTracker measurements with midsection measurements performed to USGS protocols, which is kind of the standard for flow measurement. We were actually really impressed with the results from that investigation as well. On average, the RemoteTracker measurements were within 1% of the USGS midsection measurements. I've been out in the field probably for 8 years now, measuring flow in just in a variety of contexts. And the RemoteTracker project really is about winnowing down all of that experience to something that you don't need to be an engineer, something you don't need to be a scientist, something that you can use as an operator that gives you just as accurate of data, but it's just really easy to use.
So yeah, Jeff and I got together and we would spend literally hours hashing out the details of what RemoteTracker is going to look like, its user interface, every single tab, every single button. I mean, just everything would be hashed out over many, many hours. And it was from those sessions that the blueprint was laid for how the software was going to be written. Really, while I'm the software developer, Jeff and I were the ones that designing the software together.
Being a part of the RemoteTracker project has been really fulfilling in a number of different ways. It's been really satisfying to see an idea go from its conception through development and then into implementation, where the districts are actually assimilating the RemoteTracker into their day-to-day operations. We're really excited that we've been able to develop a product that meets a need for these districts, and it does it in a way that's cost-effective, efficient, and accurate.